Hello friends, today question. Figure shows two blocks placed on the smooth surface. A force F kT starts acting on 3 kg block starting from t is equal to 0. Column 1, so this is the table. Column 1 lists the value of the friction, coefficient mu and the force constant k. So column 1 is consisted of mu and k. Column 2 lists the time instant when slipping starts between 2 kg and 3 kg. So this is column 2 in which time is given for slipping, whereas column 3 lists the velocity of 3 kg block at that instant. So this is column 3 which gives us the velocity when the slipping starts. This is the basic figure. We have 2 kg and 3 kg. Between the ground and 3 kg there is no friction, and between 2 kg and 3 kg there is a friction coefficient is given as mu and force kT is being applied on 3 kg. So we have to answer these three questions. Okay, so let's try it one by one. So the basic thing which we should remember whenever we consider this type of block over block condition. Okay, so this is, it states that relative sliding between the blocks starts when the common acceleration reaches the maximum possible acceleration, which is the maximum possible acceleration. Okay, so we are going to use this concept in order to find out the various acceleration that are being associated with 2 kg and 3 kg. Okay, so we say let the both blocks are moving together. Okay, let both blocks 2 kg and 3 kg move together with acceleration A. Okay, they move together with acceleration A. So this is 2 plus 3 and we have a force F which is given as kT and it is have acceleration A. So we can easily write the equation for A. We can say A is equal to F upon 5 and F is kT. So we can say that our acceleration A is equal to kT divided by 5. Okay, this is the value for the acceleration. Now let's find out the various forces that are acting on 2 kg and 3 kg. So this is our 2 kg block and this is our 3 kg. On 3 kg, a external force F which is equal to kT is being applied, and there is a friction between 2 kg and 3 kg. So 3 kg will try to move 2 kg along its direction of the force. Let us call that friction force Fr, and equal and opposite force Fr will be acting consequently on the 3 kg block also. So we can say that based on this diagram for block 2 kg, the maximum acceleration let us write A max such that both blocks 2 kg and 3 kg move together. They move together. So we can write our Amax will be equal to the force Fr divided by the mass, that is 2 kg, and Fr we already know is given as mu 2g divided by 2. 2 goes with 2, so we have maximum acceleration Amax is equal to mu g. Okay. And we already provided the initial hint that the both blocks will be moving together when this maximum acceleration Amax is equal to the acceleration A, when they are moving actually together. Okay, so we can say for blocks 2 kg and 3 kg to move together, A should be equal to Amax. So we already know A is our kT upon 5 and Amax is mu g. So from here we can write that T is equal to mu upon k g5. Okay, if taking g as 10, okay, let us say g is given as 10 meter per second square, so we can say our T is equal to 50 mu upon k. Okay, 50 mu upon k. So we can say that if slipping starts at T is equal to T naught, then T naught is equal to 50 mu upon k. 50 mu upon k. So in the table 1 we are given various values of mu upon k. So these are various values of mu and k. For every value of mu k we are going to find out the T naught. So first value of mu is given as 0.1 and k is given as 1. So we can use this equation to find out T naught, which will be coming as 5 seconds. Similarly, for every value of mu is 0.2, we have k is given as 2. So we get T naught is equal to 5 seconds. Next value, mu is 0.2, k is 1, so we get T naught as 10 seconds. And the last is mu is 0.1 and we have k is equal to 2, so we get T naught is equal to 2.5 seconds. So different values of mu and k, we found out the time at which slip is going to take place. Okay, in the first part we are asked that I pick the correct option. Okay, So we are going to identify what are the various combinations for the mu k, time, as well as our velocity, which is given in third column. Okay, so we can clearly see that there is option we match it to 1:1. Okay, so we can say that when our mu is 0.1, k is 1, and t naught is equal to 5 seconds. Okay, so we have our, this is 1, it means for first part. Then we have time as second, so this is third. Now we are going to find out what will be our velocity. So this velocity will be either p, it means 10, or it will be 2.5. Okay, from one of these options we are going to identify. We already know that value of acceleration a is given as kt upon 5. Okay, and so for this we know that for mu is equal to 0.1 and k is equal to 1, we can say our acceleration is equal to t upon 5. So acceleration t upon 5, and it is given that starting time t naught is 0 second and sleeping time is t naught is equal to 5 seconds. Okay, sleeping time is already, it is t naught is 5 seconds. So we are going to find out our velocity. Okay, so velocity v will be equal to integration of a, which is equal to integration of from 0 to 5 t upon 5. So this will be 1 upon 5 t square upon 2, 0 to 5. This is 1 upon 5, and this will be about 25 upon 2, and this comes as 2.5 meter per second. So it means for velocity v, we have 2.5 meter per second. So we can write it here that this gives us a velocity of 2.5 meter per second. So we can say that 2.5 meter per second is q. So option number A is the correct option. Okay. So this is our option A. Okay, so option A is the correct option. Now in the B part, in the second part rather, pick the option corresponding to maximum value of the instant when the sleeping starts. Okay, we are going to find out maximum value of the instant when the sleeping is going to start. So once again we come back to this table, and we are going to find out the maximum value for which the sleeping is going to start. From here we can check the various value of time t naught for which sleeping is going to start, and from here we can say that t naught is the maximum value at which the sleeping is going to start. Okay, so we can say in the second part, the maximum value of t naught when sleeping is going to start is t naught is equal to 10 seconds. Okay. And from here at t naught is equal to 10 seconds, mu is 0.2 and k is 1. Okay. From here we can say mu is equal to 0.2 and k is equal to 1. And once again we are going to find out the velocity part. Okay. So we already know velocity is integration of acceleration, and that will be integration from t naught is equal to 0 to 10 of acceleration is given as t upon 5, because, well, let me write here k a is equal to kt upon 5. K is 1, so this comes about t upon 5, and this is equal to 1 upon 5 t square upon 2 and 0 to 10. So we can say velocity will be coming as equal to 1 upon 5 into this will be 100 divided by 2. Okay. And this goes by 20 and this goes by 10. So from here we can say velocity is equal to 10 meter per second. Okay, 10 meter per second. So we can say that for option, because we already found out that value of k mu is 0.2 and k is 1, so we have this third option from here, and maximum time is 10 seconds. So we have here either it will be this or this, because here it's second, and last is you can say velocity, so it will be either s is 1.25 or p is 10. So here we calculated that velocity is 10 seconds. Okay, so this will be our correct option. Now in the third part, pick the option corresponding to minimum speed of 3 kg block at the instant that slipping start. So we are going to find out the option at which the speed is minimum of 3 kg block at the instant when the slipping is going to start. From the table itself, we can see that the minimum value of the velocity we are going to find out. Okay. When the slipping is going to start. So we have this third part. So we are going to minimum speed of 3 kg block at the instant slipping starts. At the instant slipping start. Okay. So in this case, mu is 0.1, k is equal to 1, and t is equal to 2.5. Okay. So we once again we can say use the same formula, that our velocity is equal to integration of acceleration, and acceleration is equal to kt upon 5. Okay, so we have our acceleration from 0 to 2.5. We have here t upon 5, and this is 1 upon 5 t square 0 to 2.5. So this, divided by 2. So this is 1.5 into 2.5 into 2.5 divided by 2, and we get this as this goes by 0.5, and this will be coming as, where it is, yeah, 1.25 divided by 2. Let me check. Sorry, k is 2, my mistake, I missed it. K is 2. Okay, so we get this as 2 by 5, sorry. So 2 by 5, 2 goes with the 2, so this will be coming as, so velocity is equal to 1.25 meter per second. Here this k is 2, mu is 0.1, and t naught is 2.5 second. So here corresponding we get velocity is equal to 1.25. So we can identify that option number A will be the correct option. This one. Okay. So option A, correct option, and here it is option D. Option D. So this completes the question. Thank you.